Most people do not realize how much slides affect the success or, more often, the downfall of a scientific presentation. First, during the process of creating slides, presenters make important decisions on what to include and, equally important, what to leave out. For that reason, slides affect the scope and depth of presentations. Second, slides influence the delivery of a talk. While the best presenters address the audience and speak from what they know, weak presenters lose courage and read from their slides, often reading bulleted lists in a mind-numbing style. Yet a third effect of slides comes in the comprehension of the content by the audience. Our research at Penn State has found that an effective slide design, such as the assertion evidence approach, can lead to statistically significant improvements in audience comprehension. What do scientists and engineers themselves think about the slide shown in a scientific presentation? Our surveys of hundreds of scientists and engineers from 4 different continents reveal many different complaints. But by far, the number one problem cited about slides is having too many words. Sadly, examples of slides with too many words abound in science and engineering. Actually, it is not surprising that having too many words is the number one complaint. In the late 1980s, psychology researcher Alan Pivio found that even though spoken words are taken in through the ears of an audience member and written words are taken in through the eyes, both of those verbal inputs, spoken and written, are processed in the same part of the brain. Building on this work, another psychology researcher, John Sweller from Australia, posed the following question: if both spoken words and written words are processed in the same part of the brain, could that part of the brain become overloaded, much as a central processing unit of a computer could become overloaded by performing too many tasks? So, Sweller performed experiments and found that if audiences tried to read too many words while simultaneously listening to someone speak, the audience becomes overloaded and comprehension drops dramatically. In fact, Sweller found that comprehension during this overload condition is worse than if the slide was not even shown. Our surveys of scientists and engineers have also uncovered 2 other common weaknesses of slides. One is that many slides in scientific presentations are cluttered, so cluttered that the audience is not sure where to look while the speaker is talking. Another weakness is that much text is too small to read. This weakness is a particular problem when the text is important, such as for the axes of a graph. So why do these problems continue to be issues in scientific presentations? In other words, why haven't our presentation slides evolved to address these issues? Many researchers laid the blame on the defaults of PowerPoint, which was created back in 1986 by an entrepreneur, Robert Gaskins, and a computer scientist, Dennis Austin. An important thing to know is that the original defaults for PowerPoint were not based on any research for how people learn. Rather, the defaults arose from what these 2 individuals could create with the computer architecture of the day. Worse yet, these defaults have not significantly changed since the mid-1980s. These defaults run counter to how people learn. First, the default for the nested bulleted list in the body of the slide leads presenters to put too much text on slides. Second, this same default takes up much valuable space, which reduces the size of graphics. Third, the default for the headline causes people to write a short phrase. Now, at first glance, having a phrase headline might seem advantageous because you are writing fewer words. However, research has found that a phrase headline is not an effective filter and leads presenters to include too much information in the body of the slide. In short, PowerPoint's defaults are lousy for scientific presentations. We can do better, much better.